Okay, this is the regression models notes. You'll need to copy everything that's on here, and on the back of your pages, you'll be copying some pictures that I'll show you. So regression model is the process of finding the line or the model equation that best fits the data in a scatter plot with the least amount of error. A scatter plot is a plot of all the data points that don't necessarily always end up in a straight line. The linear regression equation has the form of y hat equals mx plus b. If we're using our calculators to get that on the equation, you'd push menu 461. Quadratic regression is y hat equals a times the x squared plus bx plus c. We use menu 464. Exponential regression is y hat is a times b raised to the x. The x is an exponent, not a regular variable. Menu 468 is what we'd use. So a linear regression has two forms. It has a positive form where the b or the y-intercept is low and the line seems to grow. As the change in the x, which means the distance between two x's, increases, the y increases. So you have a positive x increase, positive y increase. The other version is a negative linear where the the y-intercept is high and the line seems to fall. And you have a negative change of y, so you have a negative slope. So as the x's increase, the y decreases. Our second one is a quadratic, which has the fun name of a happy face, frowny face. If it is a upwards curve, it is positive because it falls down first, but then increases, causing you to have a minimum. This tells you where the lowest point would be. Like if something was falling and then it was rising. Think of like a plane dipping down from the sky and then regaining height. If it is a maximum or a negative, it makes the frowny face, so you have a negative slope, negative, but it creates a positive. This is the highest point. Think of throwing a ball to a partner, and the highest point that ball is, that's what it's forming. This would be the trajectory of the ball itself. The last one is exponential. You have negative decay, which means that the overall slope is curve is falling. Exponential is special because this bottom line will never ever touch the zero. It just keeps going closer and closer and closer, but never hits it. As your x increases, as you move along the x, your y continues to fall, but never actually hits zero. The positive growth starts really close to zero, never touching it, and then continues to grow. Think of things like viruses. Viruses have positive growth where the number of days increases, the number of virus bugs will increase. Decay is the opposite. This is like the number of people that are dying from or things that are decaying, such as things that are decaying, such as radioactive isotopes for nuclear warheads and stuff like that. When a nuclear bomb goes off, it immediately starts to decay, and over time it gets closer and closer to zero. It never really goes away, but it will be. It eventually does get small enough that it's not a problem. Okay, so we have some vocabulary that you need to know. You'll be quizzed on. A data table is an XY table. It shows the information organized in rows and columns. These would be your points in a table form. Domain is the set of possible values of the independent values, which is the x values. Range is the set of all output values, y values of the function when a given x is entered. So if you have 1x plus 3, then you put 1 in. 1 times 1 is 1, plus 3 is 4. Your entry is the domain, the x of being 1. Your output is your range, which is 4 in this case. X-intercept is the x-coordinate where the point of the line or the curve or the surface intercepts with the x-axis. So it cuts through the x-axis. In that case, your y is 0. your y-intercept, the point where the line or curve crosses the y-axis on the graph. At this point, x is 0. Graphical analysis, the method of analysis which performs graphing by taking the input from data and tables. Basically, it's talking about making graphs. That's what it's talking about. Maximum or minimum value is the largest and smallest value of a function, either within the range or within the entire domain. So with the quadratics, the minimum or the max would be the lowest or highest point that the y could be within the range. If it is something like the exponential, the minimum would be at 0, actually a little bigger than 0 because 0 would be excluded. Okay, so we're going to do some examples using our calculator. So you're going to enter all your data into the calculator. Push Control Dock, and then push Tab, pick X, push Tab, pick Y, and then put menu 461, and that will give you your equation. Now the example is going to give you this equation over here because I put in the years. If we pull and the back arrow, it will get you back to your list. And now push menu 413 and you'll find the R squared. So to continue and go on to the next question, you're going to push push dock 41, and that will allow you to have a new problem number. And then you will type in your data, pick number 4 to get a list, type in your X and your Y, and then type in your numbers. All your X's and all your Y's. And then you're going to again do Control Dock, pick number 5, push Tab, pick X, push Tab, pick Y, and it looks like a frowny face. So we believe it's quadratic, so we're going to push menu 464. And that gives us the equation of negative 0.261 x squared plus 22.591 times x plus 23.029. I am rounding to 3 decimal places, and that's what y equals. Now, if we want to solve for a piece of it, use that equation to actually find what's the highest point. We have to actually do one more step, which requires us to do another Control Dock. This time we're going to add a graph, and we're going to enter our equation. Now there's 2 choices. You can type in the equation you've written down, or you can use the var button that we used in the past and pull from there. The computer knows what the A, the negative 0.26 is, the B, 22.591, and the C is using the var button. So I'm going to use the var button, A times X, and then we need to square it, plus push the var button again to get B, again times X, and then plus var again to get C. It's really important you put pluses between each one, even if you have a minus sign on your paper, because the calculator already knows it's minus. It will do its spot, it will fix itself, and then hit enter. Now obviously my picture is pretty big, so here's what we're going to do. We're going to menu 4, 1, and we're going to change the settings so that they match our data. So our data starts at 20, so my min needs to be slightly smaller than that. I'll pick 10, and my max is 70 for x's, so I'm going to go up to 80. And I'm going to force it to count by tens. And then for y's, my y's need to be pretty big. My smallest is 323, so I'm going to pick 300 and then go up to a little bit more than 500, so maybe 600. And then I'm going to count by hundreds. And that gives me a window that shows my actual thing. Now, notice it says stat A instead of the numbers that we tied, but that's still the same equation. Okay, so now I want to find out what the maximum is. I want to find right about where that point is. So I'm going to push menu. I want max, so I'm going to push 6 and then 3. And then I have to put my dots on either side of that maximal spot, and then it gives me my points. So at 43.2 degrees, I've reached 511, but it's asking me at what angle, so I need the 43.2 degrees. 1/1000. Okay, now we're going to do a exponential. Again, push closes, just go to new doc. Pick 4, go up and put your x and y in your list. And if you notice, the y's appear to be dropping. This is a clue that this is a decay instead of or a negative slope, one of the two. We don't know yet which one. So again, you push Control Dock, pick number 5, tab it to get your x, tab to get your y, and it's pretty obvious that it's a little bit of a curve. They seem to be curving. That's an exponential, and we don't see both sides of the curve like a happy face, so we only see the one. So menu 468 gives us our equation, and you can move the equation by just grabbing it and going up. So 1018.28 times parentheses 0.569 raised to the x. The x is an exponential. Okay, and the next part of the question says how many coins will be returned on the 8th trial. The trials, if you look at your table, is your x value. So we're going to figure out, use our equation plugging in 8 where the x is. So to do that, do Control Dock again, pick a calculator, push the var button. We're going to pick A because the calculator already remembers it. And then times var B, this time caret 8, and enter. And that gives you the answer to that equation. So 16 coins, rounding off. Okay, that's all the time we have on that question. Okay, our last question we're going to do is another exponential. This one is a growth. So we're going to push dock 4-1 to get a new problem. Pick number 4 to get your list. Put your x and y in. And then type in your data. Again, if you look at your y's here, they look like all of the numbers are increasing by slight amounts, but not even. Okay, we want to see what it looks like, so Control Dock, pick number 5, tab X, tab Y, and this one almost looks like it's a line. So we know it's an exponential growth because that's what the example tells us. So we want to zoom out just to get an idea of how it would look. So if we push menu, zoom, and we're going to zoom out, and we're going to put our thing as really close to the 0 as possible so we can kind of see what's going on. And they kind of still look like a line, but they're also kind of doing a little bit of a curve. Now we can do one other thing, and let's go ahead and put in what the equation would look like. So regression, we know it's exponential, so 4, 6, 8, and you'll see that they are right on that line. If you want to zoom back in, you can zoom out, and you'll see that there's definitely a line going on there. Okay, so our equation is 379.92 times 1.04 raised to the x. If we want to solve for the equation, we want to figure out what's the stock worth in 10 years. We'll do Control Doc, pick a calculator, and then we're going to use the var button again, because the calculator already knows what the A is and it already knows what the B is. We just got to tell it what the X is. So A times var B, again, caret to we're putting in 10. And that gives us 562.37, which is 562. Let's say we had a question that was a little backwards to that one. Instead of saying, what is it worth in 10 years? Let's say, how long for stock worth, let's say $1,000. Now this is a Y value. 1,000 is a Y. So this time we're going to push menu for 3.1 first to get in solve, and we're going to tell it, oh well, we know our answer is our Y value is 1,000. So we're going to say Y 1,000 equals, and we're going to say the A times the B raised to the X, comma X. A and B is in your stat list in the var button. What we don't know is your X. So you'll push var stat A times var stat B caret, and this time we're going to use the variable X instead of the number, comma, and then we're going to put X. This tells the calculator, I want you to find out what X is if Y is 1,000, and then hit enter. So basically in 25 years, 24.67 years, that stock should be worth $1,000. Okay, so that's how you would get future values. Where the other question we were looking for is how much do you need? How much will it be worth in 10 years? This is how much it's worth in 10 years. This is how long it would take to get it to be worth 1,000. So that's the end of the note.